What about quantities in a chemical reaction? Let me talk about the Haber process. It's my favorite. Nitrogen plus 3 hydrogen goes to 2 ammonia. This chemical reaction changed the entire world dramatically. That's kind of another story. I guess let's not do stories today. But at any rate, in terms of molecules, there's a ratio in this, right? How many one molecule of nitrogen reacts with how many molecules of hydrogen?
6.
Well, that would be 6 hydrogen atoms. So actually, we could do atoms if you want. In that case, this nitrogen here is actually 2 atoms with 6 hydrogen atoms. Yeah, but let's go back to molecules. How many molecules?
3.
Yeah. So 1 molecule of nitrogen reacts with 3 molecules of hydrogen and makes, I'm going to put a little equal sign. What happened? Am I losing you guys yet? We have 2.5 minutes and we'll have to start another session, but okay. So why is it doing that? What's going on here? Okay. Well, let's just move it up. All right. So, and how many molecules of ammonia will I make if one of those reacts with 3 of those? I'll make 2 molecules, right? All right. So and actually, well, the atoms, I guess that would be, there'd be a total of, if one NH3 has 4 atoms, there'd be a total of 8 atoms, right? But that's less important. So let me actually, can I scratch out the atoms? I don't want them there. They're a distraction. Okay. What if I had 100 molecules? So I had 100 nitrogens. How many hydrogens would react?
300.
Perfect. And how many ammonias would I form?
200?
That's correct. I mean, if this is a 1 to 3 to 2 ratio, I can multiply this by any number. A 1 to 3 to 2 is also a 100 to 300 to 200 ratio. Or, I mean, if you wanted to, we could do tens. Maybe, you know, this could be a 10 to 30 to 20. But, all right, let's do a bulk number. What if I have dozens? So I have 1 dozen nitrogen would react with how many hydrogens?
3 dozen.
Perfect. And how many ammonias would I make?
2 dozen.
Perfect. Okay, again, the mole is just a bulk number like a dozen. What if I have moles? So 1 mole of nitrogen will react with
3 moles of hydrogen to form
3
2 moles of ammonia.
hydrogen, and I will make 2 moles of ammonia. That's perfect. Well, anyways, these are ratios, right? 1 mole of nitrogen equals this one. Okay, so it's a counting operation and it's exact. Let me go back to the mole subway. Let me take what we did last time. We can go from grams of X to moles of X using the molar mass. And we can go from moles of X to molecules or atoms. Let's just say molecules for now, using Avogadro's number. And so this is the new thing. I can go from moles of X. Yeah, you know what? We did do this in the lab. I'm basically doing this all over again. Now I remember. It's okay, though. I had this on the whiteboard. You guys remember this at all? I hope you guys remember this.
Yeah, I have pictures of it.
Okay. I thought that was a pretty good lecture, actually. It did. So anyways, we can go from moles of X to moles of something else in the chemical reaction using the mole ratio. And those are the coefficients in the balanced reaction.
Guys, like the
Question? Was there a question?
Disappeared.
Oh, I'm sorry. If you guys, it's okay to ask the question. If you want to ask the question, we can stop for a sec. I didn't hear it, but okay. Also, once we get to moles of Y, then we can also, there's a subway on the other side. I can go to grams of Y using the molar mass. I can go to molecules of Y using Avogadro's number, right? And so let's bring back that equation. NH3 plus 3H2 goes to 2NH3. If 10.5 grams of hydrogen, or maybe we should just do moles first. Excuse me. Let's do moles first. If 3.8 moles of hydrogen react completely, comma, how many moles of ammonia will form? Question mark. So for this, we have to, which stop are we on? Which stop are we at and where are we going? Where are we here? Where are we? If we have moles of hydrogen. So usually also, like I like to start over here. This is what I call the known. And over here, this is usually what I'm trying to find. I'll call the unknown, right? Now, so which one, what is my known? My known is the 3.8 moles of hydrogen. So I'm here and I want to go there, right? So let's do that. So we have 3.8 moles of hydrogen. And then what is my mole ratio of hydrogen and ammonia? Anybody? What's the balanced chemical reaction say?
3 moles of hydrogen.
3 moles of hydrogen to 2 moles of ammonia. So where do I have to put the 3 and where do I have to put the 2?
3 at the bottom, 2 on the top.
Good. 3 moles of hydrogen on the bottom to cancel, 2 moles of ammonia on the top to find out about. Okay. How many sig figs is this one?
2.
Good. That's 2 sig figs. What about this one here?
1.
Well, actually, it's a counting operation. I said it's exact, so it's actually infinity. So sorry, that's okay though. So then my answer should have 2 sig figs, right? Okay, so I'm gonna get in my calculator. Clear, and 3.8, whoops. 3.8 times 2 divided by 3. That's pretty straightforward, huh? And then, okay, so 2.53333, but to 2 sig figs would just be 2.5 moles of NH3. Okay? So this is the quintessential new idea that we're doing, right? This thing here. This whole, that whole thing is the only new thing. Now we don't have to start at moles and go to moles. We can start at grams, go grams to moles to grams. There's a lot of different pathways here. I could go grams to moles to moles to molecules. Or I could go molecules to moles to moles to molecules, right? You know, there's many different ways. You have to read the problems really carefully.
Are there any shortcuts, or do you have to do like go through all those steps?
There's no shortcut for this one. And for that one, you have to have a balanced equation. Let's do a different problem. If 10.5 grams of hydrogen react completely, comma, how many grams of nitrogen reacted? Question mark. Okay. And this one to me is kind of a really common kind of problem where I'm given a mass of one thing and I want to find the mass of another. And so I could write out a set of steps for these if you guys would like. Would that be okay? I mean, but in a sense, you're just kind of putting it together. So for me, step 0 is have a balanced equation. If you don't have a balanced equation, then you're just guessing at the end of the day. You might get lucky if it happens to be 1-to-1 or something. And then the second step is use, or I guess that if the 0, if that's the 0 step, the first step would be use the amount of the known, usually grams, comma, to find, to find grams of the known. And then once I've done that,
Unknown.
I'm sorry. Gosh, I totally ruined this. Sorry, Mr. Teacher. Use amount of the known to find not grams, but moles. God darn it. I'm so sorry. Okay. Anyway, 2, use moles of the known, what you just found, to find moles of the unknown. And I'll go through this whole thing in a second. And then lastly, use moles of the unknown to find grams of the unknown. Or actually, let's make it more general. Let's say amount. It could be molecules, yeah? That's why I didn't put grams up here. I said amount, usually grams. Okay, so let's do this then. So if I have, so step 0 would be NH2 plus 3H2 goes to 2NH3, balanced equation. Step 1, so let me actually, I want to put these together, but step 1 would be, I had 10.5 grams of hydrogen. Let me put this more close, and then times 1 mole of hydrogen over 2.02 grams of hydrogen. Did you guys need to see me calculate the molar mass of H2, or is that okay?
Are you on step 0 or step 1?
I'm sorry. So step 0 is this, the balanced equation. So let's go back. So step 0 is balanced equation. Step 1, use amount of the known to find moles of the known. So here's this. My known was the 10.5 grams of hydrogen. So this is my known, and I'm converting it to moles. Yeah. Okay. Now I'm gonna add step 2 directly to it. Step 2 is, so if these grams cancel with grams here, I have moles of hydrogen. So now I'm going to use moles of hydrogen to find moles of moles of nitrogen. We want to, this is a different problem, huh? Because let's go back to the question. How, if 10.5 grams of hydrogen react completely, how many grams of nitrogen reacted? All right, so what's the mole ratio between hydrogen and nitrogen? Let me put a parenthesis. That's not a coefficient. Or put a circle it. Okay. So what's the mole ratio between hydrogen and nitrogen?
3 to 2.
Okay, I have a 3 here. What's in front of this?
1. Sorry.
There's secretly a 1 in front of it. So it's 3 to 1. Okay, where does the 3 go and where does the 1 go?
On the bottom, 3 goes on the bottom, 1 goes on the top.
3 moles of hydrogen on the bottom, 1 mole of nitrogen on the top. So now I'm going to cancel moles of hydrogen with moles of hydrogen. So if I did this divided by that, now I would have moles of nitrogen. That's step 2. I found the moles. I used the moles of the known to find the moles of the unknown. So then step 3 is use the moles of the unknown to find the amount of the unknown. And in this case, we wanted grams. So I'm going to want 1 mole of nitrogen on the bottom to cancel, and that's equal to 28.02 grams. And I could show that calculation if you guys would like to see that. But that's the process. Oh, I guess we could calculate it. Okay, so calculator. On clear 10.5 grams of hydrogen divided by molar mass of hydrogen, 2.02, times 1 divided by 3, so divided by 3, and then times 28.02. So I can just do that in my calculator, multiply and multiply, divide, as long as I don't have any exponents, right? If we had exponents, then like I was talking about before, I would use a parenthesis. And then what do we get? We get, it looks like 4.8549 times 10 to the 1. So, oh, how many sig figs? How many sig figs is this?
3.
3. How many sig figs is that?
3.
3. How many sig figs is that?
Infinite.
Good. Counting operation. How many sig figs is that?
Infinite for the 1, but 4 for the grams of nitrogen.
I would say for the molar mass is 4. Yeah, the 1 comes about by division, so it gets ignored. Okay, so my answer should have 3. Let me put the equal sign down here. So I want 3. So 4.85 times 10 to the 1, or we could just turn that into a number, 48.5 grams of nitrogen reacted. Oops, is my pen going out? Okay, so there we are. And that's kind of the idea. So someone said 28.02 grams is the molar mass of N. No, so nitrogen on the periodic table is 14.01. But my formula is N2. And 1 mole of N2 has how many moles of nitrogen in it? It would have 2 moles of nitrogen. And so that's why, that's the Y for it's basically 2 times 14.01. Right? Okay. Yeah, so yes, so 1 mole of nitrogen, 1 mole of N2 has 2 moles of nitrogen atoms inside of it. Does that, because, you know, one, here. I guess I'm out of paper, I'll just flip it over. So 1 N2 has 2 nitrogen atoms. Yeah? Does that make sense? Okay, I think it's clear then. And so I could do the same thing. I could multiply this by 100. 100 N2s would have 200 nitrogen atoms. 1 mole of N2 would have 2 moles of nitrogen. Yeah. Okay. So be careful, I guess, is the cuidado. All right. Be careful, because that will happen constantly while you're doing these calculations. And be careful. I don't know. I could keep doing examples. Before we go further, do you guys have any questions?
I actually have one question.
Okay.
So I wanted, I don't exactly know, like, from, you know how you were talking about the stations, different stations, like in the little bus, train, or whatever it is?
Oh, the mole subway. Yes.
Yes. So what exactly are we doing for this problem? Like, where are we starting for this problem?
Okay, so you see my subway here?
Uh,
So we went from grams of hydrogen to moles of hydrogen, moles of hydrogen to moles of nitrogen, and moles of nitrogen to grams of nitrogen. So you don't always have to go from reactant to product. I could go from reactant to other reactant. Or technically, I could go from product. I could say if I made, 40 grams of this, how many grams of that reacted? But whatever they give me the amount of, that's my known, right? When they gave me, where did it go? When they gave me 10.5 grams of hydrogen in that first question, that was my known. And then the nitrogen was my unknown, right? So that's really careful to, that's the known. And the thing that, and when it says how many, question mark, that's my goal. Oops, got cord over here. There's a way to tether it or something. So this thing here is my unknown, right? That's what I want to find. That's the eventual goal. That's the points on the test, yeah? So it's really, there's other skills involved. You want to read the question. I'm writing these very simply, but you want to read the question. You guys want to, I could back up and we could talk about problem solving in general. So, I guess the main point is be careful. Most commonly, you're going to go from grams of your known to moles of your known to moles of your unknown to grams of your unknown. But that's not the end of the story. You could also go down to molecules, right? Or you could find molecules. You really have to read the questions carefully.